Question 2 from Section 2 of the 2023 Higher Physics exam from the SQA. An adult with a child is cycling along a straight level path. The child is in a trailer which is connected to the bike by a tow bar, as shown in the picture. The combined mass of the bike and the adult is 85 kilograms, and the combined mass of the child and trailer is 28 kilograms. The forward force on the bike and trailer is 125 newtons, and there's a frictional force of 45 newtons acting on the bike and a frictional force of 15 newtons acting on the trailer. And for 2 marks we have to show that the acceleration of the bike and trailer is 0.58 meters per second every second. That's a show question, which means from the data there we have to show that the answer is 0.58 meters per second every second for the acceleration. Let's start off with a diagram. We'll represent the diagram of the bike and the trailer with these 2 blocks here. And we know we've got a mass of the trailer, and the mass of the trailer is going to be 28 kilograms, so we can put 28 kilograms into the block here, just a quick sketch. And then we've got 85 kilograms for the bike and the adult. Now we put in the forces which is acting on it. We have a forward force acting on the bike and trailer, and the forward force is 125 newtons. So if I put in 125 newtons there, that's the forward force. But we've got frictional forces acting on the bike and trailer. This is the frictional force acting on the little trailer, and that's got a value of 15 newtons. So we can pencil it in as well, 15 newtons in there. So we're building up a diagram of the forces and the mass on this system. The other frictional force is acting on the bike and the adult, and that's given a value of 80, it's given a value of 45 newtons. So there's a picture there. Forward force 125 newtons acting on the 2885 kilogram system, and 2 forces of friction. So we have to show that the overall acceleration is 0.58 meters per second. All we have to do is find the unbalanced force, and the unbalanced force acting on this system is the forward force, which is 125 newtons. And we have to subtract the 2 forces going back the way to left. The frictional force always acts against the motion. So we have to subtract the 15 newtons, and we have to subtract the 45 newtons. So our overall unbalanced force should be of the value of 65 newtons. Now once we have the unbalanced force, we can then go ahead and find the acceleration. The acceleration is always equal to the unbalanced force acting on the objects divided by the mass of the objects. So the unbalanced force we know is 65 newtons, and the mass, combined mass, is going to be 85 plus 28. So we can put in there 28 plus 85. And we can do that with a calculator, and we get the following answer. We get 0.575, and it's going to be meters per second every second. So we can put that into 2 significant figures by saying 0.58 by rounding that one up. So there we have it. We've shown that the acceleration of the trolley and the bike is going to be 0.58 meters per second every second. Question 3, part B. Determine the magnitude of the tension in the tow bar. That's this part in here, and there must be a force with the tension due to the tension of the tow bar. Now the word determine means use the available data which is in the diagram, and also use any additional information that you can gather. So we do know that the combined mass of the trailer and the bike and the forces acting on it, which is worked out, is going to give us an overall acceleration of 0.58 meters per second every second. Now if we want to find that tension force in there, we bubble wrap that trailer, and to bubble wrap the trailer just means we just draw a cloud around it. We isolate it from the rest of the system like that. So as we're only dealing with the trailer. Now when we look at the trailer, we know it's going to have the same acceleration as the bike because they're joined together. So the acceleration is going to go to 0.58 meters per second every second. Now we've got the acceleration, we've got the mass, so we can work out the unbalanced force acting on that 28 kilogram mass. And we do know the force pulling it is T, And we do know that there's a force of friction pulling back away is 15 newtons. So we can write down our forces as following. The unbalanced force causing that acceleration is equal to the forward force, which is caused by the tension. Remember, we're bubble wrapping this. We're excluding this bike and carrier. We're looking at this system here. The unbalanced force is the forward force due to the tow bar, the tension. Take away the frictional force, which is 15 newtons. We'll just give it its numerical value at the moment. And we know we also can work out the acceleration. We've worked out acceleration, we can work out the unbalanced force. Because unbalanced force really equals mass times acceleration. And that is equal to the tension of the tow bar minus 15. So therefore, if we rearrange things, the tension of the tow bar is going to equal to mass times acceleration plus the 15 newtons. So what's going to be the mass times acceleration? We know it's going to be 28 kilograms. Multiplied by the acceleration, which is 0.58 plus the 15. So there we have the expression for the tension in the tow cable. When we do that in a calculator, we get an answer of 31.2 newtons, and that will be the tension, the pulling force in the cable. Question 3, part C. As the speed of the bike and trailer increases, the force of friction on both the bike and the trailer increase. The acceleration of the bike and trailer remain constant. That's a very important point here. State whether the tension in the tow bar increases, decreases or stays the same, and we must justify our answer. Now, to justify our answer, we must show either by a calculation or by some equation how we can actually explain our answer. Now, we know that the acceleration is going to be exactly the same it was before, 0.58 meters per second every second. Now, we know there's going to be a forward force acting on it. We don't know what size that forward force is. We know there's going to be a force of friction due to the bike, which is going to be acting backwards, and a force of friction due to the trailer, which is acting backwards as well. And we know there's going to be a tension in that cable, which is going to be T. Ultimately, that's what we're trying to find. Now, once again, we use our technique. If we just want to concentrate on the tension force, we will bubble wrap everything behind that tension force, isolate the system, and then just look at what we've got. We've got the same acceleration. So acceleration stays the same, 0.58 meters per second every second. So we can write out our equation now. According to this cloud here, the unbalanced force is going to be equal to the forward force, the tension, take away the frictional force acting on the little trailer. So that's our basic equation there. Now, we do know we can rearrange to find out what the tension in the cable is. The tension in the tow cable will just simply be equal to the force of unbalanced force, add on the frictional force due to the trailer. Now, we know it's the same acceleration, therefore force equals ma. This will be exactly the same. The unbalanced force is going to be exactly the same. I'm going to lock it into a box like that. Unbalanced force is exactly the same. Now, if the force of friction is going to increase, this quantity increases, then you can see in order to keep the equation balanced, then we're going to have an increase in the tension in the cable. So our answer is that when the friction forces increase, the tension in the cable will also have to increase because you're going at the same acceleration. Here's our bonus question coming up then. It's a revision of what we did previously there. We have two masses, 20 kilograms and 40 kilograms, attached with a cord or a tow rope, which is massless. We don't have to include that in the overall mass. That's why we say it's massless. And there's a forward force of 120 newtons pulling it. Now, the strategy for this is find the overall acceleration. So first of all, we find the overall acceleration by combining the two masses. So we're going to have acceleration is equal to the unbalanced force divided by the total mass. Now, there's only one force acting on these two blocks, is the 120 newtons. So it's going to be 120 newtons divided by the total mass, which is going to be 60 kilograms. So right away, I know that acceleration is going to be 2 meters per second every second. And the clue is, if we want to find the tension in this rope, we know that each of these boxes will be travelling along at an acceleration of 2 meters per second every second because they're connected together. Now, if we want to find the tension in that rope, remember our strategy. We simply isolate everything behind that tension, and that's it, like that. So then we can turn around and say that the unbalanced force is really equal to tension here. There's no backward force acting on it. So the unbalanced force T is equal to the mass times the acceleration, because there's no backward force acting on it. So the unbalanced force is just simply going to be T. So the tension in that rope is going to be the mass, 20, times the acceleration, 2. So the tension is going to be 40 newtons. And that's how you go about doing these problems. The higher question, which tries to separate you, will ask this: if the two boxes start moving at a constant speed, what will be the tension of the cable? And the answer is, if it's moving at a constant speed, there's no acceleration. So acceleration's got to be equal to 0, and therefore you can see the tension of the cable must be 0 as well. So when the two boxes move at constant speed, they are going to have no tension in the connection rod between them. That's your bonus question.